Hi, my name is Jay Wilson. I'm the Director of Generation and Stewardship at the Canadian Electricity Association. Today on the Future is Now series, we're chatting about a project out west from ATCO. And welcome, Hassam. Can you tell us a little bit about Fawcett River, Alberta?
Hey Jay, thanks for having me. Yeah, Fawcett River is in central Alberta, 2.5 hours north of Edmonton, and ATCO has a telecom site north of the river. So ATCO has a large distribution and transmission network in Alberta, and it has its own telecom network to support that electrical grid, basically.
Oh, fantastic. Okay, so what did you end up doing in Fawcett River with that?
So the telecom site is a backbone site to the Peace River and Fort McMurray um, regions. And basically, it's a mobile repeater site. Uh, the site, in the site, the site is so remote that there is no power line close to the site. As a result, to supply the telecom equipment, two diesel gensets were running 24/7 to supply the telecom equipment there. ATCO decided to convert the site to a hybrid system, which includes solar and battery and propane gensets as a backup. I was the design engineer for solar and battery system there.
Well, that's fantastic. So how did you, of all the projects that you could have done, how did you come up with prioritizing this project? How did you identify Fawcett River as the priority to make this transition from diesel to renewable?
So one of the engines was at the end of life, and ATCO had two options. One is replacing with the same asset and continue running the site on diesel, basically hauling fuel to the site, which is a remote area and that's very expensive, and continue emissioning GHG. Or the second option was replacing it with a hybrid system that includes solar and battery and propane as a backup. So ATCO chose the second option because it's cleaner and it's more cost effective. The gensets are running only up to 30% of the time, so they require much less maintenance and less frequent fuel hauling to the site. So it's more economic as well.
Great. So can you sort of take us through the phases of the project development timeline for the folks that are watching this that might not understand all the planning processes that go into a project, realizing a project of this kind of scale?
Yeah. So at the high level, I can say it starts with planning and then design and review, construction, commissioning, and then operation and maintenance. For this project specifically, we started with detailed electrical and financial modeling of the system uh, that allows us to run optimizations and have the optimized size for the battery and PV and understand how many hours the gensets will run in the optimized solution, which is the most cost effective option. And then after that, we include all the stakeholders, such as customer, which in this case was our telecom engineering group, the land and environment, the operations folks, which at the end of the day will operate and maintain the site, and put together a design basis memorandum with all the inputs from different stakeholders and all the requests. And then we designed the system, um, acquired all the permits required for development and construction, and then followed up by construction and commissioning. So um, this process can take 9 to 16 months, depending on the type of the projects and on the type of permits you need to obtain.
That's fascinating. It seems like you have a lot of different groups of people within ATCO, and then also the folks that are going to be building it, needing to bring those people together. all at once to make sure that you've got a solution that will work for everybody. That's fantastic. Wonderful. So given all of that, it sounds like it was a big challenge anyway, but what would you say is the biggest challenge that you and your team needed to overcome in order to get this project built?
Yeah. So brownfield projects are always a challenge. Integrating new technologies with the old assets is always a challenge. And in this case, our SCADA and PNC team worked really hard to configure the microgrid controller properly and make sure that the controller properly communicates to the new devices as well as the existing ones.
The SCADA and what was the other one?
PNC, protection and control.
PNC. Okay, perfect. And so could you give a quick version of what those might be for folks that don't know, like myself?
For these sites, you have to make sure that different components communicate to each other properly. And at the same time, you have to have a remote visibility of the site so that if something goes wrong in the site, myself in Edmonton or our operations team in another place, they get notifications, they go to site and fix the problems. Also, you have to make sure that the site is safe and reliable and it has appropriate protections inside. Let me go back and talk about the microgrid controller first. The controller itself in a microgrid system orchestrates all different resources in the microgrid. For example, in this case, the controller decides when the battery charges or discharges, or when the gensets start or stop, or when the solar generates or curtails, to make sure the most cost-effective dispatch happens, and also the microgrid operates safely and reliably. So to achieve this goal, we had a tremendous effort by SCADA and PNC group.
Wow. Okay. So that seems like there's a lot of moving parts on this one, and pulling these all together, it takes a whole lot of teamwork to make sure this all comes together. It's really great to know that all of these systems work together so well, and that they can come together to make sure that you're getting the optimal output that you're looking for. So where do you see the Fawcett River renewable generation project in the next 30 years as we're getting closer to achieving, among other things, the federal government's goal of reaching net zero GHG emissions by 2050? How does this project help with that, and will it evolve over that time?
Yeah, so these types of projects like Fawcett River, they will be the new normal. They're here to stay. Actually, ATCO is looking at 100% solar or a hybrid system such as Fawcett for all the new telecom sites, or the sites that the generators are at the end of the life, and we need to make a decision about replacement. Now, can you imagine how many of these sites we have across Canada? Like big communication companies such as Rogers and TELUS, they have many of these sites. RCMP, forestry, oil and gas sector, utility companies, they all have these remote industrial sites that are running on diesel 24/7. So if you're looking at a net zero by 2050, the transformation must start from today.
That's amazing. And to think that you have hundreds or maybe thousands of these sites scattered across Canada, and not only can you get them off fossil fuel, but you mentioned earlier, you have to get that fossil fuel up there somehow, which I'm guessing is you burn fossil fuel to get the fuel there, and then you burn the fuel once it's there. So yeah, I think those attributes you were talking about lowering the overall fuel amount and lowering the number of trips you have to take to get it there. Well, yeah, that's I can see how that's going to really help us get to sort of turn the ratchet down on those emissions and get closer to 2050, that goal in 2050 that we want to get to.
Exactly.
That's great. What's next for ATCO on this and for you, and can we expect to see more innovative projects like this in the near future?
Oh, for sure, yeah. Actually, right now, ATCO is in the process of commissioning a large microgrid system in northern Alberta, which supplies a remote community of over 800 people.
Oh, wow, that's great. So it is in terms of where you think it's, more complicated, less complicated. It sounds like it's a much bigger job. Would you agree?
Exactly. Yes. That one is a much more complicated project, and it involves more people. But let me save the details for later when we have this site commission.
That sounds good, because then we can do one of these again. All right. And so Hassam, I have one last question for you, and that is, if you could use one word to describe electricity, what would it be?
I would say comfort.
Comfort. I would agree completely.
Exactly.
Wonderful. Okay. Well, thank you very much, Hassam. It has been a real pleasure to talk to you about your project in Fawcett River.
Thanks, Jay.
Take care.
You too.